Alright students, you've got me recording. I'm going to show you guys how to do the graphing really quick. So, you see the graph, hopefully you see my mouse. At the bottom you've got 0, 1, 2, 3, 4, 5, 6. This represents the time in minutes. By the way, time is our independent variable, but also the literal word time right down here is our title for our x-axis. Temperature is the title for the y-axis, and it goes 80, 90, 100, 110, 120, 130, 140. The title for the entire graph is temperature moderation graph. So, getting started with this, I'm going to show you guys exactly what you ought to be doing. Let's go ahead and switch to our data. First things first, we look at our variables. We've got time here, and literally all these different liquids are being measured in temperature. And at the end, your thing should end up representing each of these liquids up here. So let me go ahead and get a copy of that. And it should look something like this. Let's go ahead and zoom in on that. Where each of the liquids is represented by a different color, and it stops at the 6th minute, which is where we stopped recording. By the way, each of these lines, each of these numbers represents that line. That's why each of the dots is on the line. It's not in between. It's not, on one of the lines that's unmarked. It is right on this line, okay? Because that's when we took our recordings, right on the line. So, moving back to our data, we go ahead and look at it and we say, all right, let's do liquid C. I'll do liquid C for you. Or no, I gave you guys liquid A. I'll do liquid A again. So, liquid A, I say, all right, liquid A, what's the color for liquid A is going to be? Liquid A can be, let's go ahead and get a little brush in here. Let's, how do I change colors? Alright, well, there we go. Liquid A is going to be red. A is going to be red. Beautiful. Look at that beautiful A. Anyways, hopefully that'll work. That's perfect. Okay, so liquid A is going to be red. We look at liquid A and we say, all right, at 0 minutes, it's 79.9 degrees. We go over to our graph and say, all right, here's the 0 minutes, because remember, this is our time. It's measured in minutes. 0 time, and it's 79.9. So each of these is going to be 5%, 80, 85%, 90, 95%, 100. So if this is 80 and this down here is 75, we can just mark this right here, because this is 79. So that's our first point. Then we go ahead. Oh, wrong one. Go ahead back to our data and say, all right, liquid A, minute 1. What was the heat? 103. Go to our first minute, because we just looked at minute 1, and our heat was 103. So 80, 85, 90, 95, 100, 105. So it's going to be somewhere in here. 103 is going to be right up at here. And we put our dot right on the line, because this is the time that we measured it. We measured it at 1 minute, not at half a minute, not at a minute and a half. We measured it exactly at 1 minute, so it's got to be this line. So then we do that for each of our ones. So I'm just going to go back and forth a couple times. Liquid A. What is it? Second minute, 105. Second minute, all the way up to what is 105 right there. Then we go back. Third minute, liquid A, 118. Third minute, 118. Bloop. Back and forth. Continuing reading this. 118, 118, 115, 113. Obviously, you guys are not going to do this as fast as me. 118, 115, 113. I've just done this so many times with you guys that I just remember the numbers. And then once you've got your numbers, again, this one is not a number. We just made that on accident. Once you've got your numbers, you can go ahead and draw lines. And this is going to be your first line. literally from the data. So obviously you could copy this if you wanted, but you got to get the rest. Now, in the end, you shouldn't just have this one line. You should have literally all of your lines, all of different colors. By the way, don't pause your video and copy this one because I purposely put the wrong data on here. So I'll know if you were doing that. So yeah, you should have each of the liquids represented by a different color. And the reason that we do this is to be able to compare them. Because when you look at a data sheet, you're like this, and you're like, hey, which one of the liquids was most similar? You look at them and you're like, I don't know which freaking liquid was similar. Look at all these damn numbers. Well, when you look at it on a graph, you can just look at it and be like, you know what? The gray one and the pink one were kind of similar. They kind of bent around in the same way, and one of them was just a little bit hotter than the other. So you can make those kind of comparisons because it's on a graph. It helps you, again, like I said on your notes, it helps you figure out patterns and understand data easier. So that's what you're doing for your homework. I did A for you. You got to do B, C, D, and the control on this data sheet. All right? And also, one last bit. I've decided that I will give you extra credit if you do. Let's zoom out a little bit. The cohesion graph on your own as a bar graph. This is a line graph. If you do a bar graph for all of the averages of the cohesion data, I will give you extra credit. A bar graph looks like this. Look at this. Bar graph is going to look like this. Son of a gun. Fine, perfect. My favorite type of movie, bar graph. If you have something like this for the cohesion data averages, then I will give you extra credit. All right, get to it. Good luck.